Okay, so we spent a lot of time talking about end behavior, intercepts, behavior at intercepts, how many turning points, how many x-intercepts, all this stuff. Let's put it together and actually graph these polynomials. Now, what I mean by graphing is not art. We're not after a perfect picture here. We want something that shows that we understand how this polynomial behaves. So I had an ugly one here. I decided not to do that. Let's start with this. If you go back to the last video, this is, I believe, the last one that we factored. So we have x cubed plus 9x squared plus 14x minus 24. And we factored it to get x minus 1, x plus 4, x plus 6. Now let's look at the various parts of this equation in both forms, the multiplied out and the factored form, and see what it tells us about our graph. Our leading term tells us some stuff. It tells us our end behavior. It's positive. So that tells us our graph goes up on this end. And it's got an odd degree, which tells us our graph goes down on the other side. Our constant term is negative 24. So that's going to be our y-intercept, negative 24. And again, I don't care how high or low the hills and valleys go. So I'm just going to negative 24 anywhere I want on the y-axis. Because it's a third degree, it can have as many as 3 x-intercepts and as many as 2 turning points. And we know we've got x-intercepts at positive 1, negative 4, and negative 6. And we also know, because of the multiplicity of those zeros, that the graph's just going to go straight through at each of those. So can we fill in the rest of this shape so that it obeys all of these things, goes straight through at those 3 places, hits that y-intercept, and goes the right direction on the ends? I can come up right through there, through the y-intercept, through the x-intercept at 1, and then up to infinity. I don't need that arrow there anymore. Okay, there's my graph, and it shows me exactly what I need to know. Where and how it crosses the x-axis, where it hits the y-axis. The book actually doesn't talk too much about that, but I think it's so easy, why not? It gives it to us for free, right? And I got the right shape and end behavior, and I've got my 1, 2, 3 x-intercepts and my 2 turning points as predicted. Okay, that is the basics of graphing. And we can also check just by popping this in the calculator. I don't happen to have it in the calculator, but you can graph it in your calculator, and you will see that the x-intercepts, y-intercepts, etc. are in the right place. Let's look at one that may be a little bit more complicated. It's got a couple things wrong with it, quote unquote wrong. We have a number in front of our leading coefficient, which isn't the end of the world, but does complicate things a little bit. And we don't have a constant term here. So what I'm going to do right off the bat is I'm going to factor out an x. So I have x times 2x cubed plus 3x squared minus 8x plus 3. Okay, so that's a factor, and that tells me something. That tells me that this is going to cross the x-axis at 0. So I got one of my x-intercepts already. Now I can use synthetic division to factor this, and we will, but remember we need to figure out what numbers to put in. So I'm going to cheat a little bit. I'm going to put this in my calculator first, and I've already got it in there, x to the 4th, the original 2x to the 4th plus 3x cubed, etc. And I'm going to look at the graph. And I'm going to guesstimate about where that crosses the x-axis. It looks to me like it crosses the x-axis at negative 3. And I can test by doing trace. I can put in negative 3, enter, and it'll say negative 3, 0. So yes, I know negative 3 works. It also looks like it crosses at 1. Okay, so it does. It crosses at 1, 0. I can use that information to help me with my synthetic division. Okay, I didn't leave myself maybe enough room here, but let's give it a shot. I only have to factor the one that's left in the parentheses there. So 2, 3, minus 8, positive 3, and it looked like 1 worked. So 2, 2, 5, 5, negative 3, negative 3, right? Just bring that down and then multiply by 1, add, etc. And that gives us 0 indeed. So there's our next polynomial. I've got a factor of x. I've got a factor of 1. Oh, sorry, a 0 of 1, which means x minus 1 is a factor. And then it looked like the other one was at -3. So let's try -3. That'll give me 2, -6. -1 times -3 is +3, which gives me my 0. Okay, so now I've got a third factor of x plus 3. And my last factor here is 2x minus 1. Okay, so I got my original form and my factored form. My factored form tells me I have an x-intercept at 0. I have an x-intercept, I'm going to have to make a bigger scale here. I have an x-intercept at 1. I've got an x-intercept at -3. And this one, if I set this equal to 0 and solve, I'd add 1 to both sides, divide by 2. That'll give me 1/2. That's my fourth intercept. Okay, so this tells me my intercepts, and the multiplicities tell me that it's going to go through at each of those. And if I go back to my other form here, 4th degree positive. So my end behavior is up on both ends. Positive tells me this end goes up. Even tells me the other end goes the same direction. And I have as many as 4x intercepts, which I've already got, and as many as 3 turning points. Okay, that's all the information that we get out of these two forms of the graph, or two forms of the equation. It's got to go straight through, there, 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 and up. Okay, and that gives me a little better idea. It's an ugly picture, and it's not terribly accurate. These lobes here or whatever go much higher and lower than the ones that I've drawn. But if we look at the graph, it's easier to understand from my graph what's going on in this area than it is by looking at the calculator screen. I know that it's crossing at 0 and 1/2 and at 1. All right, that's it for this. We'll come back and do one more next time.